working in the professional measurement division, where we focus on utilities, construction, GIS, and the forestry markets. So I'd like to introduce our other two guest speakers. Scott.
Yes, this is Scott Hunter. I'm the Natural Resources Account Manager at Juniper Systems. I specialize in applications like forestry, log scaling, fisheries, mining, and a lot of other market segments that have similar data collection needs.
John?
John?
Hi. Thanks, Derek. Scott. I'm John Calkins with Simpson Lumber Company. I'm a log scaler of 38 years with a 2-year forestry degree. I was given a great opportunity with a great company, Simpson, to deploy my experience with log scaling and inventory management at all 5 of our Washington mills on a weekly basis.
Okay, thanks, guys. We're just going to quickly go over what we're going to cover today as far as the agenda goes. Derek is going to describe just the basics of laser technology and kind of go into the 101 mechanics of all the sensors that are included in our technology. We're going to also then cover over some true pulse models that can handle these types of measurements that we're going to cover today. And then Juniper Systems are going to pipe in, talk a little bit about them, and then again more a little bit about their background in this industry, and of course their newer improved products. And then going right into the LogDeck software solution that works on a Juniper data collector that is designed by Laser Technology. And then John will certainly share throughout this presentation his experiences with old methods, new methods, and that sort of thing, and just talk about the field procedures and what that looks like when doing LogDeck volumes. And then just a little bit about us from a laser technology standpoint. You know, we've got our really good opportunity actually in the early 90s where we kind of got started in this industry. We developed a laser for NASA, and it was designed for, it was a proximity sensor that measured both speed and velocity and distance for space docking missions. It was so successful it became standard equipment moving forward. And then also in the early 90s, we partnered up with Bushnell and kind of co-created the very first recreational rangefinder. This was designed for golfing and hunting, and we're still active today in designing their all their lasers, which are one of the more popular products that Bushnell offers. And then this last image to the right here is basically the very first handheld reflectorless total station. We integrated both a laser, a tilt sensor, and then incorporated a compass, and then we're able to even perform laser offsets, and this again was kind of in the early 90s. So we definitely have had a lot of experience in lasers. That is our core business, and we've been doing it for over 28 years. Derek?
A little bit about laser 101. There's 2 types. Your first type is a phase laser. You usually see this in the total stations where you need to have a prism or a second person to acquire the targets. Laser technology, we focus on the pulse laser, aka reflectorless technology, where you can get a measurement to any type of surface, to the log deck or chip pile or even a tree in the field. We incorporate this in our laser rangefinders. We've got a distance sensor built in and a tilt sensor in a True Pulse 200 model here. The distance sensor measures that slope distance or line of sight distance. And then the tilt sensor measures that inclination or tilt of the unit itself. With those 2 different values, we're able to calculate the vertical distance and the horizontal distance that's used mainly in mapping applications. Taking it a step further, we incorporated a compass sensor along with those other 2 sensors, the distance sensor and tilt sensor. The compass sensor works off of magnetic north, and so with those 3 values, we're able to get that slope distance, inclination, and azimuth or bearing values, so we're able to calculate that XYZ value. In case you encounter magnetic interference or work around heavy machinery, a compass can be compromised. So we developed a horizontal angle sensor. We developed that into a true angle. Now, taking our True Pulse 200 that measures that slope distance and inclination value, the horizontal angle sensor will measure that turned angle. You've got to establish a 0 reference. So with taking the values that X, Y, and Z, or the values of slope, distance, inclination, and the angle value, we were able to calculate that X, Y, Z coordinates of your object. Scott, could you talk a little bit more about Juniper Systems itself?
Absolutely. Yeah, the Juniper Systems, the parent company of Juniper Systems is Campbell Scientific, and you may recognize them. They're one of the top manufacturers of stationary data loggers and data acquisition systems. In the late 80s, one of the Campbell brothers, Ron Campbell, he branched out and started making rugged handheld computers. And one of our first customers was actually log scaling type customer, and we officially took on the name of Juniper Systems in 1993. And Juniper Systems conjures up some images. Most people, when they think of Juniper Systems, they think of some of the videos we've made showing handhelds being shot from slingshots or dropped off roofs or thrown into lakes, even put under a truck or dropped in concrete or sealed in concrete, dropped off a roof or something like that. That's really our specialty, is making the world's most rugged and professional industrial-grade handhelds. This kind of shows the product evolution. Going back, our products have changed a little bit in the last 20 years, and what's interesting is how many of the previous products are still going strong in the field. This is our current product line. Each handheld caters to different preferences, but each is really they follow the same theme of being rugged and reliable, and they're each waterproof, dustproof. You know, they're built to perform optimally in real world conditions, and each will work seamlessly with laser technology products. I'm going to highlight the Archer 2 quickly because that's the device that you have the opportunity to win from laser technology through this webcast. So the Archer 2, like other Juniper Systems products, it offers maximum data protection. It's got the IP68 rating, MIL standards, so it's going to be waterproof, dustproof, built to endure and perform in any conditions. The display is the first thing that grabs people's attention. We took the best screen available and we used a special optical bonding process together with some chemically strengthened glass, and the result is a screen that's virtually scratch-proof. It has incredible brightness in any conditions. And along with that, the battery power is outstanding. It has a lithium-ion battery that's 2.5 times more powerful than our previous products. So with the screen at full brightness and other power-hungry applications like GPS going, it'll go for 20 hours, no problem. And lastly, I just put that it has it all. It's got it all, because there's a wide variety of configuration options available for the Archer 2. And I also just wanted to comment that Juniper Systems and laser technology have been used hand in hand for a long time, and the products really complement each other very well.
Well, thanks, Scott. And hey, John, how did you get involved with Juniper Systems and also laser technology?
Well, you know, log decks are so large and misunderstood that it's difficult for folks to get involved. So I discovered that there was really a limited number of folks who were willing to step into this adventure. You know, I didn't supply this slide that we're looking at right now, but it just happens to be Weyerhaeuser Longview that my wife and I first started our scaling career in 1976. It was when I left the Scaling Bureau and went to work for Simpson Lumber, we had our crane issues up in Tacoma. Next slide. That we were trying to figure out the best method to measure these high decks. And, you know, the problem was getting around in between the decks. And this top slide here shows kind of a dramatic squeeze to emphasize to everybody how difficult this was, which was a technique that I also used for my log quality pictures that I would share with everybody. But my first experience with laser tech actually was on a crane in Tacoma. The old method was measuring log decks with a 50-foot pole, but the decks were 55 foot high. And it just was too impossible to do this on a regular basis, so this was only really done at audit time. So the method that I tried to come up with was using something that we all learned back in forestry school, was using a clinometer with a 50-foot Spencer tape. And they developed a procedure that one person could walk down a log deck and take shots and get a higher degree of accuracy. The problem was that after all the measurements, only half the work was done, and the inaccessibility of many of the decks that you spent so much time and great lengths to get the best information you could, you were ending up guessing at many of the other log decks. So the goal was, because of my experience of riding our crane with a True Pulse 200 tethered to a scaling computer, I had gained the knowledge at least to ask the right questions and went on a letter writing campaign. Laser Tech came through with the programming of the log deck software, which I enjoyed immensely working with these folks and their programmers. And Juniper had the scaling computer that I needed for my check scaling, which just happens to have become the kind of standard de facto here in the Northwest for all the scalers. Just about everybody's holding one of these devices.
Yeah, so working with you, John, we wanted to make sure we capitalize on all the goals and your procedures that you had out in the field, and so we developed a software solution called Log Deck Volume. And again, listening to the customers and the issues you've seen out in the field, is we wanted to develop a simple way to collect the data with our laser rangefinder on top of a Juniper System products. So we developed 5 different mapping methods. You have all different types of applications or environments in the field, so we developed these 5 different mapping methods. This first method is the baseline method. That's more of a simple method. A user is going to set up an origin, maybe set a cone, the traffic cone there at one end of the log deck, away from the deck. And what you're going to do is you're going to work along parallel the length of the log deck using the laser rangefinder and the software. And you start to walk along that baseline until that you see a break or a peak and valley of the deck itself, the top of the deck. And you take a measurement to the origin, then you're going to take a measurement to the top of the deck. Then you're going to move to the next break or valley. You take a measurement to the origin and take a measurement back to the top of the deck. And you work your way to the length of the deck and take that last measurement back to the origin. The software, as you can see here, there's just a quick screenshot, walks you through everything. So it knows you're taking those measurements correctly, back to the origin and then the top of the deck. It's one of the simple method using a True Pulse 200 product. The other method we developed is called missing line. We have a routine in the True Pulse 360 product called missing line, where you can take a measurement to 2 remote points, and it'll calculate that line segment between those 2 remote points. And this is if you're on level ground. You establish a position safe away from the deck, and you're going to use the True Pulse 360 in the missing line method. You take a measurement, so we're doing these little line segments from 1 to 2, 2 to 3, 3 to 4, and the software will capture all those different line segments. Again, you can see it drawn, the quick diagram here, and the software walks you through there, taking those missing line segments. That's if you're on level ground. We all know a lot of milliards and areas aren't on even ground or level ground, so we need to develop a procedure for uneven ground. This is still utilized in that True Pulse 360 product and that missing line method I was talking about. You're going to do a next step is taking that missing line segment. You're going to go from 1 to 2, and then you're going to need to take a missing line segment from 2 to the base. You need to be aware of where you're taking those measurements to the top of the deck to the base of the deck. And then you're going to take your next measurement line segments from point number 2 to point number 3, and then from 3 to the ground. And you continue this along the deck, getting all the peaks and valleys of the log deck and work your way to the other end of the log deck. The software, quick screenshot showing you the next steps, what you need to do, taking measurements from the origin to the first peak or valley, and then taking from that top portion of the deck to the base. The next method is traverse with encoder. It's where there might be some magnetic interference. The last method I showed was using with a True Pulse 360 where it's got the compass built in, but you might have a lot of machinery or an area where there might be some magnetic interferences out in the field. That's where you're going to use this method with the encoder. You're going to use a True Pulse 200 that measures that slope distance and inclination, and you're going to use the True Angle where it does the turned angles. It does not work off of magnetic north. So you're going to take the equipment and set up a nice safe location away from the log deck. And you don't have to be at the end of it, or you can be right in the middle of that log deck. Just position yourself here. And this is where you're going to take just the measurements to those peaks and valleys. All you're going to do is take a laser measurement, and you're going to get that slope distance, inclination, and that angle measurement to point number 1. Then you continue to point number 2, 3, 4, etc. And if you need to move, make sure you acquire all the points along the log deck, you might need to traverse or move that control point. Well, this method allows you to do that. You set up a cone, a traffic cone, along the length of the deck, and then you just take a measurement to that cone, move the equipment to that area, which is your new control point, and you continue taking those measurements to the top peaks and valleys of the deck, finishing off 12, 13, all the way to 17. Again, the software walks you through everything, gives you a little diagram. You can see if you've missed a shot or a measurement went above the log deck, it'll populate here. You can delete that shot. So it draws that diagram right on the data collector for you. Another method is traverse with Azimuth. Again, we're going to use the True Pulse 360 with the compass that's giving you that azimuth value. Same type of procedure as the traverse with encoder, but you're just using the True Pulse 360. Establish a control point, nice and safe away from the deck, and you're going to take those measurements to the peaks and valleys. If you need to traverse, you can go ahead and move, or if you need to move along the log deck, you can go ahead and take a measurement to a new control point, move to that control point, and finish off those points at 15, 16, and 17. And that's if you're on level ground. Again, not everywhere these decks are stacked, there's always on level ground. So we had to come up with a procedure to do on uneven ground. This is using the traverse with azimuth value, and you set up a position, and you're going to take one extra step. This is where you need to be aware of what the software does. And within the software, you're going to need to activate the top button. You're going to take measurements to the top, those peaks and valleys. Make sure that top button is activated, and take those measurements 1 through 10. And then you're going to tap the bottom base button, make sure that's activated. Then you're going to take those measurements to the base. Basically, what we're doing is contour, or we're doing a profile of the base also. You're doing a profile of the top, those peaks and valleys, and you've got to do the same to the base to establish that base ground. If you need to traverse, you're able to do that, move down along the log deck with the traverse button, and continue to take those top measurements to the peak and valleys, and then also at the base. Establish those two profiles. The software here, you can see it just walks you through there, draws up that diagram. And one thing to note is about the traverse target height. If you're traversing, the software populates that up as a traverse target height. So I know, John, you work with this stuff out in the field a lot more than I do. I was wondering if you can share your expertise using the software and your best practices.
Well, Derek, thank you. And it's obvious, anybody listening to this is obvious that these folks know exactly what they're doing with their equipment to be able to explain it like Derek did. The one thing that I wanted to do is make sure that it was as portable as necessary. And I explained to the group that on the top of a log deck, it's fairly easy for us to look at these all the time, that each one of those logs has a name. And we can point to one log on the top of a deck, and we can traverse down the deck and come back and start again. So that's precisely what they were able to do for me to get this set up with this software. And the software is very easy to use. They've created a very easy menu system. You start with a new job, and I always created a date and I did this on a weekly basis at all 5 of our sawmills. And so there's one of our log yards there. I picked a species, And then they gave me the ability to put in a grade and a sort, and then you begin to measure the deck by setting the origin, and they even have a backstop set up so that if you're trying to shoot down to a flat end on a deck because it has a backstop or is up against a bank or a wall, it lines up correctly for you. What I use is the TruePulse 360 with my Allegro handheld scaling computer, and this is what the screen looks like. And I have it set in traverse with azimuth mode, and the instrument height, I'm 6 foot tall, so my eye is 5.5 from the ground, and so that sets the instrument height, and I'm getting ready to shoot this deck. As I take my beginning shot on the origin side, the picture is a little bit squashed. This deck is actually 50 feet high and about 350 feet long. It has about 1 million board foot Scribner. So I'm probably 100 feet, maybe 150 feet back from the deck. I can see the entire deck, the top and the bottom. So this is a pretty good deck to stand in one spot and take all my shots. As I work my way across the top of the deck, I look for valleys and peaks and obvious areas that I need to take my shots into. And it builds a profile with the software on screen so that if you happen to miss a deck and shoot the deck behind it, that deck's going to be higher and you'll see a spike, and you can very easily back that poor shot out. And also you can work in either direction to fill in any gaps or hills or valleys that you intended and thought you might have missed. So it doesn't matter which direction you take these shots. And then I continued all the way down to my last deck shot.
Yeah, that's important, John. Like you mentioned, you can actually, as you said, you take that last shot to the left, you can come back and take some more measurements. The software allows you to do that.
Then, as you can see, all you have to do to get the full profile of the deck is there's a little button. It's a toe shot button. It's the second button down on the left-hand side, and that sets it so that you can take all your bottom shots. Now, normally the decks are on ground. They're not necessarily level. They're sloped. So if you know, they might be 2 feet higher you on one end and 2 feet below you on the other end for drainage. So I always take shots, no matter how flat I think they are, using the method here, and it helps keep the accuracy of these decks. So I'm able to take all the toe shots. And as you can see, as you take the shots across the bottom, it takes that, one of my old bosses liked to call it string theory, and stretch that right out so that you can get the right volumes in there. This works very, very slick. And in the end, you end up with a profile of the deck, and you can double check your shots. You can always back one out and replace any. And then you can look right down and hit your calc button, and what you end up with is the length of the deck on the bottom, and you end up with the square foot area. And you have the ability to put a log length and a constant in. One of the things I tell everyone is make sure you do your due diligence, because not everybody's numbers work with how the decks are being organized. But Scribner is every 3.125 feet is 1 square foot of Scribner log length, and so you can use that as a constant in most cases. And when you come away from your log deck by putting in do your due diligence on this and make sure that you understand how your decks are being built, you'll come up with some very, very respectable numbers that are very easy to repeat. And I have the experience of seeing the numbers that came from our crane and replicating them with the numbers that come from standing there and taking those very same shots with a handheld. And most of the time, they're within a half of 1% difference.
And so on this screen, you're showing all the calculations you've got there, and you can save these files, save the results in a text format or even a CSV format or Excel, so you can take that to the appropriate people. You just hit the Save button there. It saves all that information, all the data that you collected, all the points, raw data, and all these values, all the calculated values. Here's just a quick glance at the laser rangefinders and the mapping method that they can be used in. True Pulse 200 models that measure that slope, distance, and inclination are used in that simple method called baseline. A True Pulse 360 that measures slope, distance, inclination, and your azimuth value, you can use it in every method, or any method, besides the traverse with angle. Where the traverse with angle method, you're going to use a True Pulse 200 and the True Angle product. If you're if you're working around large machinery, or there might be a magnetic interference that could affect the compass accuracy. The software specifications. Our software works on Windows mobile devices, Windows Mobile 6.0 and newer. We've been working on both QVGA and VGA display screens, portrait or landscape, such as the Archer and the Juniper. And the PC program is used to install the software onto these devices.
Thanks, Jerry. I'm going to go ahead and ask some questions here. One of those questions that came through was, I think it's more directed to John. John, how long did it take to measure that scenario that was just shown? I think you mentioned that million board feet. How long did that take?
About as long as it took me to explain it. I've had people who have never touched a scaling computer or the True Pulse, and I was able to hand that to them, show them the screen. It takes about 7 taps to get you down to that the menu that you need to start taking your shots, and each shot takes about 1.6 seconds. So it doesn't take very long to move right along the top. It's very easy to sight through the 7-power scope and see your log. It's very easy to use it where you're looking in advance of where you're going to take your next shot. There's no difficulty at all. As long as if you can see it, you can measure it. There's no question. As far as the distance, I've measured as far as a quarter mile away with this thing repeatedly and come up with the same answer. But as far as log decks, we have some log decks that are 600 feet long, and to walk down and traverse them and shoot to a point on the deck that's recognizable, have no difficulty at all of walking those at a very brisk pace, especially the ones that have the channels and waterways and alligators growing between between all the submerged areas that are between log decks. Now, we don't have alligators in Washington, but we might as well have with the inability to get in there.
Great. And then one question for you, Derek, looks like it came through. What is the accuracy of the laser?
The range accuracy of the laser that we're showing today is plus or minus 1 foot, 30 centimeters in the range, and the inclination accuracy is plus or minus 1/4 of a degree, and the azimuth accuracy is plus or minus 1 degree.
Great. And then we got another question coming through. Any suggestions about how to modify the constant value?
That is the due diligence that I talked about. As an example, if you're building log decks that average 32-foot length averages, and that deck that we looked at had 1 million board foot Scribner, because we know that that's what the log receipts told us that were in that deck, and we measured it with the laser, and we came up with 10,000 square foot with the measurements, and the difference between if you divide the square footage into your Scribner volumes, you would have 100 board foot Scribner in that case, based on a 32-foot log. So all you have to do then is use the constant that gets you into that 100 board-foot Scribner. So if you take a 32-foot log and you divide it into that 100, you get your constant of 3.125, I believe. And if you have another deck that has 26-foot logs, and you know that that's what they are, then you could change the log length to 26 feet, keeping your constant of 3.125, and you would end up having the correct measurements for the deck. Now, one thing to be concerned about is a sawmill needs the proper mix of large logs and small logs many times. And so if your deliveries one time had many small logs versus many large logs, your volume on your constant can change a little bit, and so you have to be aware of that. As long as you're aware of your average log length and base it upon volume and not by piece count, then you'll be very successful.
That's great. Thanks, John. And I just wanted, looks like that's all the questions for now, and certainly we do encourage more. And if anybody wants to ask any questions, just please use that chat feature, and attention to all panelists. So we're on the screen right now where we're promoting this contest, and basically all those who have attended live to this webcast are entered to win an entire system. Juniper has been kind enough to offer an Archer 2, so it's a brand new data collector unit. And it also comes with the 360R, which is our ruggedized version of the True Pulse models, and that has that compass in it, and it comes along with the supporting hardware. So everyone, again, who has attended live gets their name in the drawing. If you actually came and saw us at the Oregon Logging Conference just a few weeks ago, that was another chance. So those were two names. And then the final chance could still be, if those who are even here online can certainly go to a survey. So Derek, if you can go to that next slide. If you take the survey, if you just go to lasertech.com/FSMS, and at the very bottom of the page, you'll see this little link here, and it says take a survey. So if you take a simple survey, it won't take you more than probably 5 or 10 minutes. That enters your name into the same drawing. So that increases your chances and gives you up to 3 if you were able to, touch point us at the Oregon Logging Conference. Obviously, you're here today if you take the survey. So we will be announcing that winner probably in about a week or so. We're going to collaborate all the registrants and attendees, and we're going to do a random drawing and announce that winner. So we'll be able to do that through an email blast and let everyone know. This is also being recorded, so if anybody is interested into reviewing this with anybody else that they work with or any other colleagues, that will be available in about a week as well. And here's slide is talking about, we're also offering a special pricing. So we encourage you to contact your local authorized dealer. The offer is actually going to be good to the end of May. And so anybody that is interested in purchasing the software, now's the time, certainly. And again, you can take advantage of the special discount pricing for attending this webcast. And then here's some contact information on both Juniper Systems and Laser Technology. So if certainly there's any inquiries about the Archer 2, there's a website, an email there. And looks like that's a misprint. I think you're still on. Scott, what is your website address there?
It's junipersys.com, JUNIPERSYS. Yep.
Okay, it looks like obviously that's the same. It looks like for your email. So sales@junipersys.com. And again, just contact us. If you go to our website, go to the professional measurement sector, you can go to where to buy, and that will lead you to an authorized dealer in your area. Doesn't look like I got any more questions at this point in time. I just wanted to thank Scott Hunter, John Calkins, and Derek Rash for their time today and their presentation. And we're going to go ahead and conclude. So again, thanks everybody for joining us, and we'll get this recording out to everyone very shortly. Thanks, Derek.
Thanks, everybody.
Thank you.
Thanks, fellas.
Okay, and we'll conclude. Thank you.